Hey everybody. So in this video, we're going to look at indefinite integration. And this is where we just evaluate an integral without any limits. In the next video, we'll look at definite integration, where we do have limits. So we've been asked to integrate the root of x minus 1 multiplied by the root of x plus 1 with respect to x. So the first thing we're going to do is expand out these brackets, so we're left with an expression involving powers. So for question A, we'll have the integral of root x multiplied by itself, which is just x, root x times 1, negative 1 times root x, and negative 1 times positive 1, which is negative 1, all integrated with respect to x. And then we can see that this positive root x and negative root x will cancel, so we're left with this. And when we integrate x minus 1 with respect to x, we add 1 to this power of x, so this becomes x squared, and then we divide by this new power, so x squared over 2. And then this negative 1 becomes negative x. And we need to plus the constant of integration. Okay? For part B, again, we need an expression involving powers. So we need to divide the x by the 2x cubed and the 5 by the 2x cubed. So all I've done, I've just split up this fraction. And then when we simplify this fraction, we can pull out this 2 as a half. And then we can use rules of indices. We get x to the 1, take away the 3, so x to a negative 2. And when we simplify this, again, we'll pull out the 5 over 2, and this becomes x to a power of negative 3 on the numerator. And again, this is all integrated with respect to x. So now we can evaluate each of these integrals separately. So we'll add 1 to this power, and this gives us negative 1. Then we'll divide by the new power. We'll do the same thing here, and we'll add the constant of integration. And now we can tidy each of these up. So we can bring this negative 1 over to here, and this becomes negative a half. We get x to a negative 1. And we can do the same with this negative 2. We'll bring this out to front, and we'll get negative a 4 and 5x to a negative 2. Now this is a perfectly valid final answer. I personally like to write these as fractions, so we get negative 1 over 2x minus 5 over 4x squared plus c. Okay, let's try some more questions. Okay, so in this example, we've been asked to evaluate the integral of x cubed plus 1 over 2 root x with respect to x. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so I'll come back if you had a go. So the first thing I'm going to do is I'm going to rewrite this integral with this division of 2 out in front of our integral sign, because this is just a constant, so this would become all of this. And then we can separate this fraction, and then use the rule of indices to write each of these as the power of x. So we get x to the 5 over 2 plus x to a negative 1 half. And then we can integrate each of these with respect to x. So we'll add 1 to this power, and we get x to the 7 over 2 divided by that new power, plus adding 1 to this power, we get x to the 1 half divided by the new power, plus the constant of integration. And when you divide all of this by 7 over 2, this is the same as multiplying it by 2/7. And dividing by a half is the same as multiplying by 2. So then we can expand out this bracket, and we get 1/7 of x to the 7 over 2 plus x to the half plus that c. Okay, let's try one more question. Okay, so for this question, we've been asked to show that the integral of this is this. So again, perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so I'll come back if you had a go. So our first thing we're going to do is split up this fraction. So we get x squared divided by x squared and 1 divided by x squared. And this becomes the integral of 1 plus 1 over x squared dx. then we can write this as a power of x, and then we can integrate the 1 and x to the negative 2. When we integrate the 1, we get x. When we integrate x to the negative 2, we get x to the negative 1 over negative 1 plus that constant. And then we can tidy this up, so we get x minus 1 over x plus c. So we've worked out the integral, but now we need to make it look like what we have here. And you can see we've got x over 1 minus 1 over x. So we need a common denominator. So if I write this as x squared over x, now we can write this as a single fraction. So we get x squared minus 1 over x plus c, which is exactly what we've got here. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. I'll leave a link in the description below.